Let's consider different forms of energy. Now, energy is the ability of an object to do work, and the units of energy are joules, or sometimes kilojoules. Energy can transform from one form to another, and when that's happening, work is being done. So let's have a look at these different forms of energy represented by these pictures. So you have kinetic energy, that's movement energy. Chemical potential energy stored inside that battery. Thermal energy, also known as heat energy. Gravitational potential energy, that's when an object falls under the influence of gravity. And elastic potential energy, that's when you build up potential to move something through a coiled spring or a rubber band. Let's think about thermal energy first. So this is heat energy, and it's a type of kinetic energy or movement energy because particles are always moving, and the hotter something is, the faster the particles will be moving within that object. So let's consider a candle, a barbecue, and the sun, and think about whether you can order them as the least energy, thermal energy, and the most thermal energy. Obviously, the candle has the least thermal energy, it's the least hot. The sun is the hottest, and the barbecue somewhere in between. Kinetic energy is also known as movement energy. So out of these three, which of them is moving the fastest and therefore has the most kinetic energy, and moving the slowest with the least kinetic energy? In this example, a flying aeroplane has the most kinetic energy, it's going fastest. A parked lorry has no kinetic energy, it's not moving. And a cyclist riding a bike is moving. The other thing you need to consider when thinking about kinetic energy is how much the object weighs. So if we had three objects all moving at the same speed, but one was much heavier, one was a medium weight, and one was a very light mass, then you would be able to tell the difference in kinetic energy, because although they're all moving at the same speed, the one with the heaviest mass would have the highest kinetic energy. Gravitational potential energy is the potential or the likelihood that energy can be released and work can be done when something moves under the influence of gravity. So we've got a diver on a springboard, a waterfall, and a book on a shelf. So have a think about ordering them on our continuum of most to least energy stored. So we put the waterfall with the most energy, the diver in a springboard with the medium amount of energy, and a book on a shelf has the least amount of energy. And here again, we need to think about how high these objects are and how much energy they're going to release as they fall. Here we're storing energy in elastic form. So have a think about a catapult, a pogo stick, and a stretched elastic band. So the pogo stick is going to store the most energy, the catapult in the middle, and the elastic band the least amount of energy stored within, ready to do work when it's released. And the last one, chemical potential energy. That's the potential to do work stored within chemicals, and as they react, they release their energy. So we've got some wood, some coal, and some jam donuts. And you'll notice they're all the same mass. So which would release the most energy and which would release the least energy? Did you get that right? A kilogram of coal will release the most energy, then a kilogram of wood, and then 13 juicy jam donuts. If we look at the amount of energy in them, 24,000 kilojoules for every kilogram of coal that's burned. You can release 15,000 kilojoules if you burn a kilogram of wood, and you release 14,000 kilojoules, which is just over 3,000 calories, if you eat up and digest and burn away 13 jam donuts. So let's have a look at this table with 5 different forms of energy across the top: thermal, kinetic, gravitational, chemical, and elastic, and a few different ideas of things with energy down the side here. And you've got to think about where you're going to put some ticks. So let's consider the first one, a coconut on a tree. So a coconut on a tree, coconuts grow on big tall palm trees. So that coconut is holding a lot of gravitational potential energy, because as soon as it breaks away from the tree, it's going to be released, it's going to fall down to earth, and it could give someone a nasty knock on the head if you happen to be trying to sunbathe underneath it. So you put a tick underneath gravitational energy. But some of you might be thinking, hang on, we can eat coconuts. So coconuts are also a store of chemical potential energy, because there's food energy stored in a coconut. So you could also argue that you could put a tick next to chemical energy as well. So work your way through this list. You will probably find that there's a kind of big tick, a first tick that you can put, but you might be able to argue for somewhere to put your second tick, another form of energy being either stored or released in that scenario.